Here's a fun one to start. Why did the straight line refuse to date the curve? Because it didn't want to be too committed. All right, let's dive into today's lesson on finding the gradient of a straight line. We have 2 points given to us. Point A at coordinates 2, 4, and point B at coordinates 6, 10. These points are plotted on a coordinate plane where the x-axis represents horizontal movement and the y-axis represents vertical movement. By placing these points on the graph, we can visualize the line passing through them. If you need a moment to look at the diagram and understand how the points are placed, pause the video now before moving forward. Now, to find the gradient of this line, we use the formula gradient equals the difference in y values divided by the difference in x values. That is y2 minus y1 over x2 minus x1. Looking at our points, point A has x1 equal to 2 and y1 equal to 4, while point B has x2 equal to 6 and y2 equal to 10. Substituting these values into the formula, the gradient equals 10 minus 4 over 6 minus 2. That simplifies to 6 over 4, which further simplifies to 1.5. This means that for every 1 unit increase in x, the y value increases by 1.5 units. The steeper the line, the greater the gradient, and in this case, a gradient of 1.5 shows a moderate incline. If you need to double-check the steps, take a moment to pause the video here before moving to the next slide. To summarize, the gradient of a straight line tells us how steep the line is. It is found by dividing the change in y by the change in x. For the points A at 2, 4 and B at 6, 10, the gradient is 1.5. This concept is essential in graphing equations, measuring slopes, and solving real-world problems involving rates of change. That's it for this lesson. Thanks for watching, and if you found this useful, don't forget to like, subscribe, and stay tuned for more lessons. See you next time.